All right. So, welcome to the stream at 15 after midnight. Yeah, so I'm just planning to do pretty quick stream today. Yeah. The one thing I want to get done is refactor struct definitions. So this is the component that we plug into the entity component system, or at least we are planning to. This used to be in the engine. A while back I moved it over to the scripting language, but it just stores like the constructor, destructor, all those sort of things for the ECS needs to work correctly. Yeah. So, been refactoring type def a little bit, and the main thing I want to get done by the end of the stream is we have this to-do right here. So we can't generate the struct definition before the script is compiled, like at compile time, because we don't actually know the alignment or data offset of the struct yet. That's dependent upon the target architecture, which we only know on the client, or yeah, where you eventually run the code. So right here, we're going to have to use, where are you? This data layout to figure out, yeah, to figure out the actual runtime structure of the struct. Now, since there's a standard for how alignment works, I am 90% sure that we don't actually need to extract offsets, though I still am going to, just because of editor-related features. But we should be able to just write the same exact struct in C++, and then it will just mesh perfectly with the scripting version, which is how it's worked so far. So yeah, here we just extract member offsets and member types and all that good stuff right there. And then we end the stream, because it's already late. But I felt like doing a stream, so we're doing a stream. Alright, first I am going to make sure that this looks good for now. So I also did a bit of refactoring on the script runtime earlier. We now have this dependency graph feature where you can only unload a script if nothing depends on it. So we don't get something where a script is calling functions that no longer exist, because that wouldn't be too good. Sorry, I just pulled a squirrel. Yeah, back to it. So yeah, and now this dependency graph, when we grab stuff from it, it actually returns a resource handle. So this works very similarly to how shared pointer works, in that it reports back to, well, it doesn't work like shared pointer, because I still want module, well, the dependency graph to own the references. It's in charge of keeping track of that memory. The resource handle is almost like a weak ref, if we're using the same analogy. So it reports back to a resource. So resource handle reports back to a resource, and we get a reference count of how many references we have to this resource. And then we just have exceptions that get called if certain things aren't done. So a lot of safety stuff. Nothing that actually changes the behavior of how stuff works yet. And what we are going to do first, well, the one thing we are basically going to do on this stream, get the struct extraction working, and maybe we'll try implementing it in the engine if this goes super smoothly and it's just done. So delete the to-do since we are doing the to-do. In IR module, not strings. Structs. We'll just go with S for now. And we're going to get the struct layout for module. We're going to grab the deserialized module. So we have a list of all the identified struct types. So maybe we just do that, since we do want to export every type of struct. Does it have name? Get type by name. Okay. Only question I have is, how often do structs get optimized out? Okay. Let's just go into this blind. If structs start... So, apparently, I read this somewhere. There's an optimization where LLVM, if there are two structs with the exact same members, they'll combine them and just preserve one of them. However, I don't know if that goes for named structs. So we'll see. If we have like a velocity and a position struct, both with a vector 3, would one get destroyed and then we would just be using position for velocity as well? Who knows? But for now, I think what we do is we attempt it this way. LLVM struct type see, and there was I saw a static method. Get type by name. All right. How much of that do I preserve for now? So if module okay, yeah, we aren't storing anything like tags for functions or whatnot. Though since tags might be an important thing in the future, I'll throw that in here. Make that an unordered set. Alright, so this gets us everything we need. Get size, alignment, and element offsets. And then for types, you can just use the original struct type. Oh, it wants all the constructors. Might come up with a better way of doing this later. Oh, hello, how is it going? Yeah, we might come up with a better way of doing this later. For now, I'm gonna be lazy and just fill this out when we compile. I'm doing pretty good. Just burning the 30 minutes past midnight oil, or yeah. When the urge to code hits, the urge to code hits. I think it's in here. It's not. Ah, define structs. Here it is. It's been going good. Most of it has just been the scripting language dev, which is what we are doing now as well. But it's like, I get this feature I'm working on working. We implement the data that gives us in the engine, and then we have scripting in the engine. Kind of. Like, the ECS will be working with script-defined data types, but we don't actually have an API defined in the engine yet, so it'll still be some time of fleshing that out and everything. But yeah, it's going well. Ooh, nice. For texture resolution instead of game resolution. That's super interesting. It'd be really interesting to see that on a, like, as a mod for a really old game, like the original Half-Life or something. Just those really blurry textures, and then you throw that on there, and you get probably not what the textures are actually representing, but something pretty cool. Okay, so it's more of like a... I don't want to say screen space, because I'm not sure that's what you're saying. But it's like... Okay. So is it like a part of the shader? Like part of the shader pipeline? Like what I'm really wondering is just where in... Shaders are a weird part with it. Sounds like they would be. Oh, interesting. I'd almost be more interested to see it on normal maps, thinking about it. Because, especially in VR, like, you can really see low-res normal maps, but an upsampled normal map would look really good. It's like, it's one thing for high-res textures, it's another thing for high-res normal maps, bump maps, all of the stuff that subconsciously makes you think this thing is real. Because there are real things that have like kind of blocky, pixely textures, more of an artistic decision when that happens. But you don't have real things that have bumpy, like weirdly sampled lighting, for instance. Yeah, that makes sense. That it would be super specific for each game, because like, something that works really well in like a cel shaded environment would work completely differently in a photorealistic, and then for something in between. Forgot to fill up my water bottle. I'm sad. Bug types. Okay, so that's the debug info. Don't want the debug info. We want... So this is the LLVM stuff. Struct entry, IR struct def. Okay, so we don't have an IR struct in here. We're just kind of winging it. So I think I'll do it right here. Entry def constructor sig is equal to struct context constructor signature. Let's see if Copilot can do this. There we go. I think it's a really interesting idea. Like, just as a thought experiment, I can immediately see a couple of pretty cool applications for it. So we have this filled out now. Computer vision is a very interesting field. Constructed def. So yeah, metaverse is just kind of like the general inspiration, but the more technical term I've come up with it is an asset streaming game engine. So you download the world in kind of retro 80s, cubes, like the wireframe and then the textures and all that stuff. So like the world loads in around you. So you only have to load in the parts of it that is closest to you. So it'd be really good for more so large open world multiplayer stuff. I don't want to say MMO engine because the worst thing you can do when starting a game company is jump straight into trying to make an MMO. But that's like the end goal. Couple of games before that, quite a few games before that, but that is the eventual end goal, is large virtual spaces. Let's see, we should have already extracted all the functions. So you could literally just go module, get function. Ooh, nice. Real world application is always where you get the make or break. Yeah, I can see it really working, a technology like that working really well in any environment where there's a lot of assets. So you start running into bottlenecks of just loading them in. So you could just load a lower res texture and then just upscale it until at a later date you either get the larger texture or you just keep it as the lower res one. I plan on doing something similar with my, well, I didn't plan on the upscaling part. I planned on like you download the low resolution before you download the high resolution at some point when you have the bandwidth to do that. But the technology you're talking about sounds like a perfect application for that. For large environmental assets, yes. The large mountain in the distance, the skybox, a really big tree. I can see it. We do not need destruct def here. It's just void. Because we're not passing the struct def in to be initialized. We're passing in some data. We don't know what type the data is. So whatever type the struct def is describing. Nice. Still renders the low res texture, but what the player sees on the screen is the higher resolution output of the model. Okay, so it's somewhere in the render pipeline. That's kind of funny. Look at this. So I have my own function reference, like type def here, but it's accidentally mistaken it for the underlying type. Like, yes, that's what it's actually saying, but I want to keep it pretty. There we go. Oh, not func def. We want this func ref. It's in the pipeline, but is not stored in VRAM. Okay, so it's like, so we got the pipeline, it gets generated around here, and the memory for the output just gets passed along. I guess it would just be like the output of a shader, so it technically isn't in VRAM. Yeah. Understand. I think. That all looks good. So now we can go back to here. No, I don't want... Why does it always jump to copy assignment? We want the move constructor. There we go. And then this one is constant. Nice. Shader only things is almost always desirable. Oh, that's where that went wrong. Move constructor. By its very name, second argument cannot be constant. Alright, so we now have basically all we really need, and then the editor dynamically accesses components on this. Okay. Yeah, I can see that being really useful. Let's see, so... let's do an indexed for. Right. And for games where you do need that super high detail on smaller objects, like let's say it's a VR game and you hold it up to your head or whatever, I feel like it would be possible to turn it on only in those situations. It's like, if it's out here, you know, it's fine. But, like, you hold it up. Oh, look at all the tiny details that the modelers totally added in. CS members. So this is when I'm creating. Okay. So we have the struct def. We have the contained types. Member vars. Then we don't store the type there. We use the more generic contained types. Very inspired by LLVM and how that works. We'll change that to size type. I'm not too knowledgeable on the like the shader or machine learning side. I know a decent amount of stuff about shaders because oh, this is the script project, but in the engine I have, like, you know, the whole shader compilation pipeline. Yeah, I know the terminology enough to pretend I know the rest. Alright. So now we have to decide how we want to handle type definitions. Yeah. I have the basic knowledge of how AI stuff works. In fact, when I was learning coding, my favorite book was The Nature of Code, and it had an entire couple of chapters on how to write machine learning stuff from scratch, and that was super fun to play around with. Nothing on the level of what's coming out now. It's basically just like the level of YouTuber, we made a simulated environment, simulated ecosystem sort of stuff. It is pretty simple in concept, but the correct way to do training data and everything, that's what I'm guessing is the hard part. Or not even hard, just time consuming, and then you have to train it, and yeah. So yeah, how do I want to handle types? Yeah. Oh man. Optimize. Thinking about that, optimization would be such a nightmare, because like, well, yes, I do know there's like a general idea of which part of the model does what, and you can make inferences about that. It's not like you can just go, oh, this set of nodes isn't doing anything, we'll just pull that out. So how much of optimizing an AI model is just, all right, we'll send it through the training data again, but with less nodes, and how much of it, what controls do you have on optimization? That, I guess that's a better question. That's the answer I was expecting. See how to learn and debug the mathematics of graphics programming. The best advice for that I can give is just jump right in and, you know, work fast and break things. And for the people in Twitch chat, I'm also restreaming on YouTube, so occasionally I'll get a comment there. Not too often, though. So the structure of the neural network, the input resolution and the precision, the weights, the number of learnable parameters, the accuracy, so moving all of the sliders. Oh, how did I learn to debug the mathematics for graphics? Painfully. I basically decided I wanted to do it, so I did it. And I made a lot of mistakes along the way, but that leads to a lot of learning along the way. So it's more so I choose a feature that I want to learn how to do, and then I figure out the steps to get there. Yeah. Graphics programming is just hard because there's the extra separation. So it's easy to debug code on the CPU because you can set a breakpoint. There's a OS support for stepping through and getting the values of all the variables. Got LLVM, GDB, all that good stuff. Then on the graphics side, you have this black box. You put stuff in and you hope the stuff you get out is the stuff you want. And if you don't do one of 200 steps right, you get a black screen. So yeah, graphics, it's yeah. Though I have seen like some NVIDIA tools where it's like you can click on a pixel and see all the steps that went into making that pixel. So when I get more into the actual fleshing out the graphics part of the engine, I'm definitely going to be looking into those tools. Might have to be on the Windows boot for that. I never thought of that. Optimizing compiler for artificial intelligences. Optimizing compilers are a pain. Actually, no, that would just be a void. Void destructor. Yeah. Oh, it's complaining about that. After 30 iterations. So it's just a bunch of throwing stuff at a wall and making come on, brain. Informed guesses based on the output. You know, I do that with code as well. Probably not in the same way. Destructor is a private okay, so it's just complaining that it's private. Okay. Just remember, always spend 6 hours optimizing what you could have done in 30 minutes. Alright, so we have an unordered map of types. Right. Implementing a parser is harder than a compiler. Agree or disagree? So by parser, you mean like the Lexer parser? My answer depends on if you're doing this from scratch or using a tool. If you're using a tool, I'd say parser is easier than compiler, even though LLVM makes the compilation part pretty easily. Yeah, I'd say parser is easier in both instances. Yeah, from scratch, compiler is definitely harder. The compiler can also see a lot more than you do. Like, even C++ and C, there's stuff hidden from you. Like, you can guess pretty closely, but the compiler sees everything. This is what you learn making a scripting language is the big picture is much bigger. About, I'd say 4 times bigger, maybe. If we're just going off of number of instructions. What was I doing? I've just been clicking around aimlessly. Right types. You sly dog. You had me monologuing. Respect. Inline assembly is... I've been tempted, but I haven't actually done it. Yet. Let's see. Yeah, I can... Embedded systems seems like that is where that would happen. VM type. So we're just gonna create a get type that converts from LLVM types into our script specific type def, since I want to kind of not use LLVM anywhere outside of the scripting language. That's generally how it goes. So LLVM type. This is also LLVM type, I believe. Type dev. Mutex locks are the worst. It's always like you can never figure out what's going wrong in the code. Because you run it. And then it keeps running, and it keeps running. No errors are thrown. You almost prefer an error to it just silently not working. No, an error is always better. What am I talking about? What do you mean redefinition of get type as a different kind of symbol? Is he complaining about LLVM type? Oh, so not only did you have to track down a mutex bug, you had to track it down within an already in use or like in production system, tracking down which of multiple things had sounds fun. Const type def. Why this no work? It's always one line. Usually. Or you find out that you have to refactor your entire system. This is definitely a function declaration. This is also definitely a function declaration. What do you want about? I bet it's just clashing with some other get type. So if we rename it. Maybe it's... Okay, yeah, it was just type def wasn't included. We're gonna change this back to just get type. We're gonna call this native types. I can imagine that, yeah, that would be scary. So the main thing I'm trying to think about here is, so we can throw everything into a map and it's going to be super fast. However, the problem is what happens when we start making references, like pointer types, that are referencing stuff and struct types that are referencing other struct types. How do we make sure everything gets cleaned up? I guess... But we don't want... Because yeah, what if we have one struct that has a member that is of type reference to another struct type from a different module? Don't really have a way to deal with that, to clean it up correctly. The reference type wouldn't be linked to any one particular module. Or I could just throw away my own type def and just use LLVM stuff. Then again, I wouldn't have a way to really define struct members too well. This is one thing to create all of them and just another to clean them up. All right, here's what we do. We pass a module into the getType function. Because of the way that we handle dependencies, we can live with a few duplicate types. So we'll have native types here. And then anything that isn't a native type will get stored in a module. Then again, how do I deal with one module referring to a structure from a different module? Honestly, this is something I want to think about for a bit instead of just jumping into it right away. So I think I'm actually going to leave this and come back to it later. Because this sort of issue is something where you don't solve it by just hammering your head against the wall. This is something you take a shower and it comes to you. So I think that's actually what I'm gonna do. So I've figured out 99% of how I'm gonna do this. I actually want to go to bed at a reasonable hour tonight. It's already unreasonable by normal person standards, but reasonable by my standards. Yeah, member offset was honestly the part that was going to be hardest. So I'll figure out how to manage types, get that all worked out, and then can implement it on a different stream. So I think I'm going to end this one pretty shortly. I mean, we've already gone for an hour. It's not too long. So till next time.